Hi everyone, my name is Chester Huba and today I'm going to discuss 5 topics under differential calculus, namely chain rule, higher order derivatives, implicit differentiation, derivatives of exponential and logarithmic functions, and lastly polynomial curves. So I hope you learn something and enjoy. So now we will discuss the chain rule. So before anything else, let's remember the formula. The derivative of a composite function, which is a f of g of x. What makes this a composite function? Because it is a function within a function. So first, we would get the outside part of the function. We would get the derivative of the outside portion of the function. So this would be f prime. Then copy the inside portion of the function, which is the g of x. Then we will multiply the derivative of the inside portion of the function, which is the g prime of x. So for example, I have a derivative of 20x plus 8 raised to 5. Then this exponent will be moved to the left side. So this will become 5 times 20x plus 8 raised to, this will subtract, this will be subtracted by 1 and this will become 4. Then we will multiply it by the derivative of the inner or the inside part of the function, which is the 20x plus 8. So the derivative of 20x is simply 20. Then the derivative of 8 is 0 due to the fact that 8 is constant. Now we can simplify and multiply 5 and 20. So 5 times 20 is equals to 100. Then copy 20x plus 8 raised to 4. Now this is our final answer. So for another example, we have the derivative of 5x minus 6 over 10 plus 8x raised to 4. So as you can see, this is a combination of chain rule and quotient rule. So we must remember the formula for quotient rule, which is the derivative of u over v, which is equal to v times u prime minus u times v prime all over v squared. Now we will get the values of u and v. So first, let's get the value of u, which is 5x minus 6. Then u prime, which is the derivative of u, simply 5. Then v, which is 10 plus 8x. Then v prime, which is simply the derivative of 8, which is 8. So now let's plug in our values and our formula, this formula. So first, let's copy first. Move this exponent to the left side to become 4. 5x minus 6 over 10 plus 8x raised to 3. due to the fact that this will be subtracted by 1, so that becomes 3. Then will be multiplied by this formula. So let's copy the formula and plug in the values. So first is v. Let's plug in the v. Our v is 10 plus 8x times the u prime which is 5 subtracted by the u value which is 5x minus 6 times the v prime which is 8 all over v squared which is 10 plus 8x squared. So now we can now distribute 5 to this binomial. So let's copy 4 5x minus 6 over 10 plus 8x raised to 3. Then let's distribute 5 to this binomial. So this will become 5 times 10 is equal to 50 plus 5 times 8x equals to 40x. Then subtract 5x times 8 is equal to 40x. Then distribute the sign which is negative. Negative times negative 6 is equals to positive 6. Then multiplied by 8. This will become the positive 48 over 10 plus 8x raised to 2. So now we can now combine like terms. So first copy 5x minus 6 over 10 plus 8x raised to 3 multiplied by 50 plus 48 which is 98. So 40x minus 40x is equal to 0, so we will not put 0 in here. All over 10 plus 8x squared. So now we will distribute the exponent to the numerator and the denominator so that this denominator will get cancelled. So copy 5x minus 6 raised to 3 over 10 plus 8x raised to 3 times 98 over 10 plus 8x raised to 2. So in here. So now we can now rewrite this as 4 times 5x minus 6 raised to 3 times 98 all over 10 plus 8x raised to 5. This will become 5 due to the fact that we will add their exponents because they have similar denominators. So now we can simplify this and we can multiply 4 by 98. So 4 times 98 is equal to 392 times 5x minus 6 raised to 3 all over 10 plus 8x raised to 5. So this is now our final answer. So okay, let's now go to higher order derivative. So for our first example, we have a f of x is equal to 6x 5 or 6x raised to 5 plus 5x cubed minus 3x plus 4. And we were asked to find the second derivative. So first, let's find the first derivative. So f prime x is equal to, this exponent will go to this side, then multiply by 6x raised to, this exponent will be subtracted by 1, so this will now become, the 5 will become now 4 plus this exponent will move, 3 will be moved to the left side, or to the down to the left side of the of the to the left side of the to the left side of 5. So this will become 3 times 5x squared. Then get the derivative of negative 3x, which is simply negative 3. So now this will be multiplied. So let's multiply 5 times 6x raised to 4 will become 30x raised to 4 plus 3 times 5x squared will become 15x squared minus 3. So this is now our first derivative. So we will find out our second derivative. So let's bring our exponent down. 4 times 30x cubed. This will be subtracted by 1. Then plus 2 multiplied by 15x. Then the derivative of this constant is 0, so we will not put it here. Let's just ignore it. Then we can now simplify it by subtracting by multiplying 4 times 30, which is 120x cubed, plus 2 times 15x, which is 30x. So this is now our second derivative. So this is our final answer. So we have another example, our last example. So I have y minus 5 cosine x plus 4 over x plus 6 minus 3x, and we will find the third derivative. So first we will rewrite this function. So 5 cosine x plus 4 x plus 6 raised to 1. So these two are equal. I just rewrite it so that we can simplify it easier. Minus 3x. So we can now get our y prime, or our first derivative. So the derivative of cosine x is negative sine x. So we can write this as negative 5 sine x plus negative 1 due to the fact that this exponent will be transferred here, multiplied by 4 times x plus 6 raised to negative 1 minus negative 1 is equals to negative 2. Then subtract by 3. So the derivative of 3x is simply 3. So we can now simplify. So negative 5 sine x minus 4. So if we multiply negative 1 and 4, it will result to negative 4. Then we will multiply x plus 6 raised to 2 minus 3. So this is now our first derivative. So now we'll get our second derivative. Okay. We'll now get our second derivative. So we have a sine x here. So the derivative of sine x is cosine x. So we will now write this as 5 cosine x plus negative 2 times negative 4 will become positive 8 times x plus 6 raised to negative 3. Negative 3 due to the fact that negative 2 minus negative 1 or minus 1 is equal to negative 3. So simplify. We will not simplify it because it is a simplified form already. We will now get the third derivative. For the third derivative, we have a negative 5 cosine x. So the derivative of negative 5 cosine x is 5 sine x. So minus negative 3 times 8 is equals to negative 24 times x plus 6 raised to negative 4 due to the fact that negative 3 minus 1 is equals to negative 4. Now we will get the derivative of the inner portion of the function, which is 1. Also here, which is equals to 1. And also here, equals to 1. That. So now we can now simplify 5 sine x is equal of 5 sine x minus 24 over x plus 6 raised to 4. I did this. I transferred x plus 6 raised to negative 4 to the denominator so that the exponent can be positive. So this is our final answer. So now let's solve implicit differentiation. So find dy over dx. 8 minus x squared is equal to sine xy squared. So first, let's differentiate d over dx times 8 minus x squared is equals to sine xy squared. So we will find the derivative of 8 minus x squared. So the derivative of 8 is 0 due to the fact that it is constant. Then the derivative of negative x squared is negative 2x is equal to the derivative of sine which is cosine. So cosine. We will apply chain rule. That is why we get the derivative of the outside part first, then copy the inside part of the function xy squared. Then let's multiply the derivative of the inside part of the function, and we will apply product rule. So the derivative of x is 1. Derivative of y squared, oh no, let's get the derivative of x, then let's copy y squared, then add x, let's copy x, then the derivative of y squared, which is 2y times dy over dx. So now copy this negative 2x. We will now distribute cosine xy squared to 1y squared and x times 2y times dy over dx. So we will get y squared cosine xy squared plus 2xy, which is the product of y squared, or the product of 2y and x. X times 2y is equals to 2xy. Then we will multiply cosine xy squared to dy over dx. So we will multiply cosine xy squared times dy over dx. So now, to isolate dy over dx, we will transpose this to the other side. So this will become negative 2 minus y squared cosine xy squared equals to 2xy cosine xy squared times dy over dx. So to further isolate dy over dx, we will divide both sides by 2xy cosine xy squared. 2xy cosine xy squared. Cancel this out, and we will now left with dy over dx is equal to negative 2 minus y squared cosine xy squared all over 2xy cosine xy squared. So this is our final answer. Okay. So we have another example. So we have x cubed plus y cubed is equal to 12. We'll find the d squared y over dx squared and evaluate at point 1, 2. So let's differentiate first. D over dx times x cubed plus y cubed is equal to 12. So the derivative of x cubed is 3x squared plus the derivative of y cubed 3y squared equal to the derivative of a constant, which is 0. Oh, sorry. We will now first input dy over dx because this is with respect to x. Now we will equal this to 0. So we will transpose 3x squared to the other side. So this will become 3y squared dy over dx is equal to negative 3x squared. So to isolate dy over dx, we will divide both sides by 3y squared. 3y squared. So this will be cancelled, and all is left is dy over dx is equal to negative 3x squared over 3y squared. To simplify it further, let's cancel 3. This will become negative x squared over y squared. So we know that d over dx times dy over dx is equal to negative x squared over y squared. So as you can see, we can apply quotient rule in this. Now we will remember that the formula for quotient rule is d over dx times u over v is equal to v times u prime minus u times v prime all over v squared. So now let's identify our u and v values. So for u, we have negative x squared, and for u prime, we have negative 2x, and for v, we have y squared, and for v prime, we have 2y dy over dx. So now let's input these values. So d squared y over dx squared is equal to y squared, which is our v, times the u prime, negative 2x, minus our u, which is the negative x squared, times our v prime, which is the 2y, times dy over dx, all over our v squared, which is y squared squared. So we can now simplify this. So we will multiply negative 2x times y squared, which will now become negative 2xy squared, plus it is a positive due to the fact that negative times negative is positive. So positive x squared times 2y is equal to 2x squared y, and dy over dx. Or we can substitute this value. So let's substitute this value. So let's substitute the value of dy over dx, which is negative x squared over y squared, all over y raised to 4, because we will add or we will multiply these two exponents. So this will get cancelled. This way will get cancelled. So this will become negative 2xy squared minus 2x raised to 4 over y, all over y raised to 4. So to remove this complex fraction, we will multiply the numerator and denominator by y. So let's cancel this, then this will become 5. So this will go here. So this will become negative 2xy cubed minus 2x4 2x raised to 4 over y raised to 5. So now we can factor this out so that it can be simplified. So d squared y over dx squared will become negative 2x times y cubed plus x cubed over y to the fifth. So we will evaluate at 0.12. So this is x and this is y. So we will now substitute or plug in the x and y values. So 2, negative 2. So the value for x is 1. Then subtract it. The y value is 2. 2/3 plus the x value is 1 cube, or 2 cube plus 1 cube over the y value is 2 raised to 5. So we can now simplify this as negative 2 times 1 is negative 2, then 2 cube is equal to 8, then 1 cube is equal to 1 over 2 raised to 5 is equal to 32. Then we can simplify this further to become negative 2, then 9 over we will factor 32 so that we can cancel negative 2. So 16 times 2, cancel this out. So the answer is negative 9 over 16. So this is the final answer. So now we're going to discuss the derivative of exponential and logarithmic functions. So we have y is equal to 2 raised to ln x multiplied by the logarithm of e raised to 2x plus 1 base 5. We have a product of two functions, namely the 2 raised to ln x and the logarithm of e raised to 2x plus 1 base 5. So therefore, we will use product rule. So our first function is exponential function with base 2, and our u or our exponent is the ln x. In the second function, we have a logarithmic function with base 5, which is constant. So our a is 5 and our u is e raised to 2x plus 1. So let's apply product rule. We have y prime, which is equal to copy 2 raised to ln x, then multiply to the derivative of logarithm of e raised to 2x plus 1 base 5, which is 1 over e raised to 2x plus 1 multiplied by the ln of our base, which is 5, multiplied by the derivative of e raised to 2x plus 1, which is simply copy e raised to 2x Then get the derivative of 2x, which simply become 2. Then get the derivative of 1, which is constant, so we all know that the derivative of constant is equal to 0, so we will ignore it. We will add the logarithm of e raised to 2x plus 1 base 5. Now, we will get the derivative of 2 ln x, or 2 raised to ln x, which is simply copy 2 raised to ln x times the derivative of ln x, which is ln of Ra, which is 2. Then get the derivative of the exponent ln x, which is simply 1 over x. Then we can now simplify, which will now become 2 times 2 raised to ln x multiplied by e raised to 2x over e raised to 2x plus 1 multiplied by the ln of our base 5 plus the ln of Ra, which is 2, multiplied by 2 raised to ln x times the logarithm of e raised to 2x plus 1, or raised to 2x plus 1 base 5 all over x. So this is now our final answer. Okay, stop. So now we will solve a problem about polynomial curves. So find the equations of the tangent and normal lines at the point of the curve indicated. So we have x squared minus xy plus 2y minus 2 is equals to 0 at x is equal to negative 2. So finding for the first derivative, we have 2x minus xy prime minus y plus 2y prime is equals to 0. Factoring out the y prime terms, we will have y prime 2 minus x is equal to y minus 2x. So to isolate the y prime, we will have to divide both sides by 2 minus x. Then we will cancel out 2 minus x. So what is left is y prime is equal to y minus 2x over 2 minus x. Since we don't have a value for our y, so let's find for the value of our y. Let's just substitute negative 2 to this equation. So we will have negative 2 plus 2y plus 2y minus 2 is equals to 0. And to simplify this, we will have 4 plus 4y is equals to 2. And 4 will be transposed to the other side, it will be turned to negative. So this will become 4y minus negative 2, because negative 2 minus 4 is equals to negative 2. Then to isolate the y, we'll have to divide both sides by 4, then cancel the 4, and we will have our y is equals to negative 1 half. So now we have our x value, our y value. Then we will now substitute or plug in our value of y and the value of x. So we'll have y prime is equal to negative 1 half minus 2 times negative 2 all over 2 minus negative 2. So to simplify this further, we will get 7 over 8, and this will become the slope of our tangent line. So to find the slope for our normal line, we just have to get its negative reciprocal, which is negative 8 over 7. And now we have our slope of our normal line. So we will now find the equation of our tangent line. So we will use the slope of our tangent line, the 7 over 8, to get the equation of our tangent line. So this will become y plus 1/2 is equals to 7 over 8 times x plus 2. Then we will multiply this equation by 8y so that the fraction will be removed. So 8y plus 4 is equals to 7x plus 14. So to simplify this further, we'll get 7x minus 8y minus is equal to negative 10, and that is the equation of our tangent line. Now we will get the equation of our normal line by using the slope of our normal line. So we will have, let's use the negative 8 over 7. So we will have y plus 1/2 minus negative 8 over 7 times x plus 2. Then we will multiply this equation by 14y so that the fraction will be removed and it's easier to solve. 14y plus y plus 7. 14y plus 7 is equal to negative 8x minus 16. So to simplify this further, we will get 8x plus 14y minus is equal to negative 23. So this is now our equation for our normal line.